Tuned radio frequency receiver is an old type of radio receiver, also known as TRF receiver in short. It has one or more tuned radio frequency amplifier stages, serially amplifying signals received from the antenna. The output from the last RF amplifier is fed to a detector or demodulator, which extracts the audio signal. Simplest form of a detector is a diode. Detected signal is further amplified using audio amplifiers. TRF receivers were popular about a century back and was tedious to operate. While tuning a station, each RF amplifier stage had to be tuned separately to the station's frequency. Later, gang capacitors with multiple rotors controlled by a single tuning knob was used for tuning. Still, it was difficult to achieve accurate tuning of all the RF amplifier stages together. Final output was fed to a loudspeaker or earphone. Basic concept was that each stage would amplify the desired signal while reducing the interfering ones by the tuned circuit. Having multiple stages of RF amplification would mean that the radio was more sensitive to detect weak signals. Multiple tuned circuits would reduce the bandwidth of the amplifier system and give more selectivity than a receiver with a single stage amplifier. The coils were mounted at right angles to each other to reduce magnetic coupling between them. In the TRF receiver shown in the picture taken a century back, if the circuits were tuned to different frequencies, very little signal would get through the receiver and be heard. Finding a station was a tedious process of successive approximation, going back and forth between the knobs and adjusting them for the loudest signal in the earphones. Once a station was found, the graduation numbers on the knobs were written down to make it possible to find the station again. That was called logging the station. Compare the process with the digital tuning by typing in the frequency in modern radios or by touching on the signal seen in the waterfall display. Selectivity of the TRF receiver is not constant. It is more selective at low frequency bands while being less selective at higher bands. That was because selectivity required narrow bandwidth, but bandwidth of a filter with a given Q or quality factor increases with frequency. So, selectivity decreases with increasing frequency. Amplification is also not constant over the tuning range. TRF receiver was superseded by the super heterodyne receiver, in which a local oscillator is used to convert the received RF signal to lower and fixed intermediate frequency or IF signal. The process is done by a mixer, and the process is known as heterodyning, which produces two frequencies, one the sum of the two and another the difference of the two frequencies. The difference being a lower frequency is the IF output, which is further processed, while the sum frequency is rejected using tuned circuits. In later years, integrated circuits for TRF receiver as a hobby radio project became available. One such IC was ZN414 TRF radio integrated circuit, which could be used with a few external components to make a simple amplitude modulation AM receiver. What remains is mounting this antenna and starting to test SWR tuning. All those are tough jobs. I'll do it on another day.